shit.
That's what I'm talking about.
Wait.
Okay, now, from the beginning.
Hello, everyone. This is Jules Urbach. I am the CEO and co-founder of OTOY. As some of you may know, OTOY is a computer graphics and software company, and our mission is to democratize holographic rendering. And when you think about rendering and you think about the fidelity and realism that comes from CGI and even now for games, there's this magical intersection point where you have complete and utter creative control when you can manipulate visual effects and graphics with the speed of a game engine. And I think the future of all of this is leading towards something that's similar to the holodeck, and maybe we're getting there with VR and AR. But our goal to make this accessible to everyone that wants to be a creator is very closely aligned with Unity's. And last year we were very proud to partner with Unity and integrate our software OctaneRender inside of Unity Editor. And this was made available to millions of Unity users with an NVIDIA GPU, and we're working on supporting many other GPUs. And I think that to describe how powerful Octane and Unity together are, it would be good to show what Octane is doing today for visual effects in films. And when you see these images that you're going to be shown in a little bit, just remember that this is exactly the same technology that's inside of the free version of Unity. So a lot of titles and visual effects are done in Octane. This is the opening of Westworld, and it's one of my favorite shows. Recent shows like The Crown for Netflix. So Octane's visual fidelity is second to none. It's basically a physics engine for light. There's no shortcuts. It doesn't do any tricks. It just renders reality as it should be. And that makes it very simple for artists to create beautiful imagery like this. And because Octane was built and designed to run on graphics cards, it skips over decades of legacy slowdowns that you would have traditionally for CGI. CPU rendering to get this quality in the past just would take hours per frame, and as many of our users know, it can be done in minutes per frame and now in seconds per frame. So our goal with Unity is to bring this technology to everyone inside of the tools that Unity already exposes towards cinematic rendering. You have things like Timeline, Cinemachine, and these are all great fits for Octane. Octane itself is integrated already in many different 3D tools from Max to Maya, Blender, Cinema 4D. But Unity was very different. And it offers us the ability to reach a much wider audience and to allow game developers to leverage some of the things that we've been building towards with Octane. And that includes baking not light maps, but actual holographic objects that you can then reuse in mixed reality. So as we look towards the 2020s and beyond, there's a number of trends that are very clear where I would bet that photorealism is going to be standard. It's going to be free. You're seeing extensions to DirectX with ray tracing. These are indicators that this is all going to happen, and that real-time game engines are going to be the basic creative tools for a lot of cinematic content going forward, and I think you're already seeing that happen today. And then I think the tools that will be built on those game engines are going to be very intuitive. Things like tilt brush, blocks, medium. These are the kinds of tools that I think people will be creating the next generation of content with. And of course, those will also have game elements. There's a lot of angst over whether or not linear or interactive content is going to rule, but I think there'll be a combination of both. Just like today, you'll have story elements that are designed for linear experiences, then you'll have games that are completely interactive and sandbox universes and the like. It looks like things are actually speeding up. As I was saying before, just this year and next, you're going to see Volta cards that can do really high-end ray tracing, and you're also seeing a lot of game engines that are already making really concerted efforts. Obviously, Unity is at the top of that list towards cinematic tools that compete with the traditional legacy tool chains for 3D graphics, content, and CGI. So our goal with Octane was to speed up this high-quality rendering and to do it all on graphics cards. And we started this almost 10 years ago. And every 2 years, we've had another major Octane release, and we've tackled another part of this problem. The first version of Octane was really just suitable for images. The second version, we added support for motion blur and animations. And by Octane 3, which was the current version that we released, I guess, 2 years ago now, we decided, well, we're going to go and support everything you need in the cinematic effects pipeline so that you could render the kinds of things that you guys saw just earlier, which can be put on a film or visual effects or television. And with Octane 4, which is the version that we've just released a few days ago, we're focused on real time. We want to get all of that quality to happen in real time in the viewport on a normal computer, not necessarily a super machine. And I think as we look beyond that, we know that there's going to be holographic displays, light field displays, and we'll get into that in a little bit. But I want to focus on Octane 4 and what it's going to be doing for Unity users. So Octane 4 was released as an experimental build for Windows users a few days ago, and a Unity integration will be coming up very shortly. So I want to discuss briefly some of the things that are going to be coming to Unity Editor with Octane 4. We've been able to allow the entire ecosystem of Octane DCC tools, including the ones I mentioned, to be able to not just import a cinematic asset and render that with Octane, but in fact generate all the geometry you would need inside of your Unity scene, so that if you've created something beautiful in another tool, you don't need to have it be an FBX and rebuild those materials. Now we have complete scene conversion. And with that scene conversion, we can then turn on Octane's baking, or we can even use the progressive light mapper. We can essentially have a one-click import option for any cinematic asset that's ever been created in Octane. And that includes, by the way, many of the things that you guys saw for those TV shows and those films. Those all come into Unity, and if they're able to be converted into a tri-mesh, we can bake them. And Octane can do different kinds of baking. It can do it all at once, and it can also send it to the cloud and have the cloud actually render mega textures, which is really cool, and something that we want to explore for mixed reality. We've also been working on leveraging some of the things that are coming in 2018.1, 2, and 3, like the HD scriptable rendering pipeline. So we want to do perfect material conversion and just make Octane seamlessly integrate with both the high-end and low-end material systems and lighting systems inside of Unity. Another really important piece that we wanted to target with Octane 4, and this is just a very early test, is supporting game mode entirely with a path tracer. Now, this is a very simple game. This is Tanks. It comes with Unity as a sample. But on the left is running inside of Octane, and it's running in game mode. And it's running as a path tracer. So this is really cool. Being able to actually run your Unity games with Octane quality is a holy grail moment. And granted, we're seeing a lot of efforts around that with ray tracing and DirectX, but this is not rasterization with reflections that are ray traced. This is an entire cinematic path trace viewport, no different than what you'd use for films. And so with Octane 4, one of the things that we know we need to do is we need to allow you to export your games with a runtime that includes Octane's cinematic rendering technology, and we're planning on doing that this year. So I want to do a deep dive into Octane 4 as a cinematic tool, what it does, what it adds, what changes with it, and there's a lot. It's a huge improvement over anything that we have ever released before, and I think it's also a game changer for cinematic rendering, and not just for films, but also for use cases such as how we integrate Octane in Unity Editor. So first of all, we actually have a whole different pricing model with Octane. Currently, with Unity, you get one GPU. That will be 2 GPUs, starting with the final release of Octane 4. And subscribers will be able to leverage 20 GPUs for $20 a month, get all the different plugins that you can use with Unity to really supercharge your pipeline. And then we also have an enterprise tier that we had not introduced before, but is very useful for really high-end rendering facilities. So with the new subscriptions, you have 2 devices, 2 nodes you can set up, 20 GPUs, and 25 other tool chains that you can then connect to Unity. And we can let you get extra GPUs and nodes for $10 a month. The enterprise licenses are much higher end. They support some very high-end features like NVLink, which is in the very high-end NVIDIA cards. And you can use up to 200 GPUs at once to render a single frame. And you'll also notice that there's some a bullet point at the bottom describing how many Octane bench. This is how much rendering power you have on the cloud. We're making access to our cloud rendering service available to all subscribers and all customers, and we're giving different tiers in terms of how many jobs you can allocate per day. And there's a lot of cloud rendering work that is done today for baking, for VR rendering, and I think in the future for light field rendering as well. Now the free tier is something that is really important to us. We need to have people outside of just the use in Unity today be able to leverage art pipelines and tools. And so we're going to be making about 12 different art packages work with the free version of Unity, and that includes, at the very least, it'll include Blender and maybe some others as well, which we'll announce in the final V4 release. But you'll also be able to access network rendering, and we want to really spread the wealth of what Octane can do and let people get their feet wet before they get a subscription or use the render network. So the free tier is philosophically really important. One of the things that we're adding this year that we didn't have a year ago is we have a blockchain, a decentralized version of our cloud rendering service. And we have an Ethereum token that can allow users to actually fulfill render work and pay for their licenses that way. It's optional, you don't have to do it, but it's a better alternative than mining Ethereum on your GPUs. So I want to get into the new features that Octane 4 introduces, and the first one is really a big deal for Unity and for games in general. So Brigade Engine was a product that we had been developing for years internally at OTOY, and it got a lot of attention. Everyone was asking us, when is Brigade going to be out? Because this is what Brigade would deliver. You would have real-time path trace quality graphics. It wasn't exactly Octane. I mean, it was beautiful and it was perfect, and it was very similar, I guess, to what we're seeing now with very high-end ray tracing. But Brigade actually went further. It could do path trace graphics as well. And this is running on, at the time, 80 GPUs, about 3,000 Octane bench. And you can now fit that into one machine with 8 high-end Volta cards, which is what you can do on Amazon. And this is actually still fairly expensive, but we want to try to get this quality down into something that could run on a laptop or a regular PC. And a big part of that work involves some of the things that are in Octane 4. Brigade is very unique in its capability to move objects around while you're also rendering and doing path tracing. It was never quite at the fidelity that Octane was, so merging these two over the last few years was really tricky work. This is an example of a test we did with Octane and Brigade, a pre-merge where we were running it on a special chip that could do accelerated ray tracing on a couple of watts. And I think that we can look at that and see that there's a bright future for being able to shoot a lot of rays per second on commodity hardware. So inside of Octane 4, everything that we've ever done in Brigade as a game engine is now inside of Octane, inside of cinematic renderer. And we actually didn't break anything. So all of Octane's quality, all the cinematics, those all work. But you now have game engine speed, and the difference is dramatic. So on the left, you're seeing Octane 3, where I move an object like that tumbler, and it's a million polys. It takes about a second to update the scene. On the right, Octane 4, 60 frames a second, there's 0 slowdown. So previously, moving very heavy objects was something that would really slow the frame rate down. And in Octane 4 with Brigade, there's no slowdown. So moving objects is instantaneous. The more GPUs you have, the less pixelation you get, the less noise you get. And, but in order to make any of this meaningful for video games or for Unity users, we had to make it so that moving objects around had no speed hit and could operate not just at 60 hertz, but even a millisecond. And Brigade and Octane together magically make that work. So it's not just moving objects around, it's also scaling and rotation. Any sort of transform on objects is now free inside of Octane 4, which is really cool. So this definitely is a game changer for artists. It just means that you don't have to worry about the speed hit of moving things around. You can test how lighting looks and objects interact with light while you're moving them around. And you're not limited to low poly models. You can do this with huge 10 million polygon objects in the viewport. So this opens up a lot of really interesting possibilities for creators, but also for games that can be built in Unity. And the integration between Octane and Brigade also created features that were in neither engine before this merge. And one of those is really awesome, and that's out-of-core geometry. So when you're loading large scenes, typically for film, it could be tens of gigabytes. That's more than what you have in GPU memory. So previously, Octane could only load what could fit on your video graphics card, and typically that is 6 to 11 gigabytes. That's a lot, but it's not enough to load in every possible scene you could have in a cinematic renderer or in a movie. But that's different now with Octane. Octane 4 supports out-of-core geometry, so as much system memory as you have, as much system memory as a CPU renderer would use, Octane can leverage that as well. And here's a worst-case scenario where we've got about 40 gigabytes all running in system memory. There's 0 video memory being used, and the viewport is still running at 60 frames a second, and I can still move objects around, and if I add a second GPU, it doubles in speed. This was something that really I don't think we've seen before in a GPU render, a cinematic one especially, where we can get this kind of scale and speed in the viewport in real time while having everything running in CPU memory. Now, that doesn't mean that it all has to be in CPU memory. We can actually blend things together and have part of the scene on the GPU, part of it on the CPU. In fact, we've also been testing that to really extremes with Amazon, where we have 500 gigs of CPU memory, and we have 8 GPUs. So it turns out we can do the same with 8 GPUs and with half a terabyte of scene data. So to make this happen quickly, we built a feature into Octane called Scene AI. And Scene AI looks at all the topology of the scene, and as you move objects around, it tries to figure out how to keep the speed as close to having all the memory or all the scene in memory as possible. And it works really well. In most cases, when you're just spilling over a little bit into system memory, it's pretty fast. It's maybe 80% of the speed, which is pretty good. But it's a very difficult thing to track, and we leverage machine learning to figure out the heuristics of what to keep in memory and what to push out. And it is something that AI is proving to be really interesting. So we have 3 AI features in Octane, and I have to say that the story of Octane 4, as much as I thought it would be about Brigade and real-time rendering, it turned out to be a lot about AI. And we started on that path only 2 years ago, but we started to see amazing results, like real-world results, by applying AI, not just to the scene data, as we just saw, but also to lighting. So there's a lot of talk this year at GDC and in previous years about denoising and how machine learning can be used for that. But we decided to try our hand at doing something deeper in the engine and actually allowing AI to help figure out how to shoot rays to figure out where the lights are. So a lot of the struggles that I think Unity users and even our own cinematic Octane customers have had is when you put a point light in something like Octane, which is a physically correct renderer, it's very noisy. The image on the left is an example of that. So point lights and spotlights have been really difficult to render quickly without noise. On the right, though, with AI lighting, we're able to reduce that significantly, almost by an order of magnitude. And AI lighting in combination with other layers, like AI denoising, is insanely powerful. It will get us much, much, much closer to real-time Octane quality this year. And that's why it was a fundamental feature that we knew had to go into this release. So there's AI lighting is interesting. It doesn't actually cheat. It doesn't smudge anything. It just is smart about the rays that it shoots. So if you have 200 samples, 200 rays, on the left, without AI lighting, you're just going to get a lot of noise. On the right, you'll have a very clean render. And you can see that I specifically shows the irradiance pass in Octane because this can be used for baking light maps. It can be used in real time for baking as well. So it has a lot of amazing possibilities for speeding up everything from real-time viewports to baking to light field rendering. And this is just with 2 samples. AI lighting is a really compelling and huge win. It also works in real time. So if you're moving lights around, this is with AI lighting off. You'll see it's kind of a noisy, blurry mess. But when you turn AI lighting on, immediately, and this is with 8 samples, the lights converge much better, and they're dynamic. So in real time, as you're moving lights around, AI lighting works just like the scene graph, the rest of the scene graph, 60 frames a second or 120 or more, which is pretty great. So this feeds into the last layer of our AI rendering system, and that's the spectral AI denoiser. So the denoisers that I've seen out there are good for AI, but they're not really what we needed for Octane. And we needed something that was really deep in the engine that could leverage and look at all the things that the scene is doing, that AI lighting is doing, and essentially feed that to the AI and see if it could do better than just taking the viewpoint buffer, the output of the renderer, and just denoise it. And as it turns out, by training it on the scene data deeper in the engine, including things like glass and the likes, we got amazing results, better than we thought. And we have to now do more and more domain-specific AI rendering pieces for things like volumetrics and subsurface scattering, but that's something that we're updating constantly. And the future of Octane and the future of rendering is as much about AI denoising and improving speed as it is about faster chips. It's really interesting, and I would have been skeptical 2 years ago, but I'm not anymore. So in Octane 4, you now have the ability for the AI denoiser and lighting to kick in the middle of rendering your noisy scene, right in the viewport. And when you mix that with AI lighting, you get some pretty awesome results. There's things that we don't see with the human eye, that the AI lighting, just in the patterns of noise that it saves, that helps train the AI denoiser to give you pretty awesome results. So 50 samples, this scene to get to this quality, normally it's about 3,000 samples. I thought maybe it was just me or this scene, but when we released Octane 4 a few days ago, it turns out our users are seeing exactly these results. So this is pretty amazing. To go from minutes to 1 second, that's a game changer. This is running with 2 GPUs, 50 samples, 1 second, 1080p, and it's done. So 1 second renders are about 1/60th of the way there towards real-time perfect renders. And this is something very different than a lot of the other real-time ray tracing stuff you may have seen at the show. This is fully path traced with multiple bounces of light, no ambient occlusion. It's basically rendering the physical world perfectly. And this is the holy grail, not just of cinema, but of ArchViz, engineering, the sciences. I mean, having this kind of speed is revolutionary, and we're tantalizingly close to real time. I mean, this is just with 2 GPUs. This is not optimized. I mean, this is really, you can see here, it's an internal build of Octane 4. But our goal is by the end of the year to make this running at 30 frames a second at this quality and not even see the noise, not even see the grain. And that's possible when we specifically attack real time. This is actually meant for offline rendering and baking, but it is already insanely compelling. And those reflections in that glass, that denoiser knows the light transport. It's other denoisers that I've seen are really terrible at blurring refractions. This doesn't do that. So we've got all the pieces in place to get us to real time with just a few samples, and that is awesome. Now there's a bunch of other things we're adding in Octane 4 that'll be in the shipping version shortly. That'll also be available in Unity, and that is a whole new atmosphere scattering system. So we have open shader language, which is quickly becoming a standard for shaders in the cinematic world. It's being shipped with Autodesk 3ds Max 2019. It's in Arnold and other renders on the CPU, but we have it running on the GPU, and we can leverage that to do all sorts of awesome things. So we have a whole new lighting and atmospheric open shader language system in Octane 4. And we're working on an Uber material that really helps us connect more cleanly with Unity's HD material pipeline, deep pixel output, improved subsurface scattering, and asset compression. Going forward, we are going to stop numbering Octane versions, and we're going to actually follow Unity's lead a little bit and have OctaneRender 2018.1 and so forth going forward. We're going to have so many updates that are going to happen every few months with major features that it just feels that we don't want to have an Octane 5 or 6 come out in 1 year. So Octane 2018.1 is going to follow not too long after Octane 4. It'll include light linking, which is very important for compositing workflows, and then we're also doing improved integration with Houdini and particle systems in Cinema 4D, and also just integrating user requests that come in from our very vibrant community of customers and users, both from the Unity side and also from the traditional cinematic rendering visual effects side. So previously, I was describing our role as a company in sort of this holographic rendering pipeline as being divided into 3 parts. And that is still true. We have to deal with capturing the real world, and Octane, of course, is in the middle of this, rendering it, and then delivering this holographic media, if that's the way that it needs to be experienced. All these things have been areas that we've delivered a lot of presentations on, but what's different about this year is that really these things are converging, and they have to, because in order to do mixed reality correctly, you have to be able to capture, render, and stream and share things all in real time. It has to be one system. And a lot of the work that we've been doing with Lightstage, which has been for cinematic, high-quality captures, these things have all been at the very highest fidelity. And we've been trying to bring the costs and the compute requirements down so that it all can run on a mobile device. And the render network, render itself, is the umbrella for all these pieces. And in fact, this year we're putting out an SDK for render, which will include our SDK for Octane, but also many other pieces as well. So it's our framework for developing everything relating to reality capture, streaming, light fields, Octane itself. In fact, we're porting Octane to Render, and that work is starting already. Render, as some of you may know, is also the name of our Render token, our blockchain, and there's a reason for that. The idea of publishing something to the web is quaint. In the world of the future, of the 2020s, I fully imagine that you'll have every asset and even IP rights connected through the blockchain. And in order to make that work seamlessly, it doesn't matter whether it's being authored from Unity or Blender or published through some other portal, the blockchain and being able to really track IP rights is important. And being able to develop something more than a simple smart contract in JavaScript, but doing something with the Render SDK that allows you to build really complex services backed by the blockchain, that's going to matter in later phases of our Render ecosystem. And the nuts and bolts of how the Render SDK works is that you have this front end that is pretty much WebAssembly, so you can just use traditional programming languages for the for the serial parts of the modules you create. But the backends are really interesting. We've got CUDA, x86, Vulkan, Direct3D, and Metal. And Octane, as I was saying earlier, currently it's NVIDIA only. We did a AMD CUDA cross-compiler project, which was crazy and a lot of work. But it was very difficult to really bring that to macOS, for example, where OpenCL and CUDA just are second-class citizens. So we've done about 40% of the work porting Octane over to this Render SDK. And what we're seeing is that it's actually turning out really well. The performance for the pieces of Octane that are now running on this new framework, they actually are just as fast as they ever were on CUDA, but now we have backends that run on Vulkan and on Metal. And we can now actually target macOS, which we couldn't do before, and even Intel integrated graphics. And there's millions of Unity users that don't have a discrete graphics card, so getting Octane to run on those integrated graphics is really important. So let me give you an example of where we are today with all of this work. And we have a benchmark, which is actually how we allow people to price out their cloud jobs and even get GPUs. It's called Octane Bench, and there's 3 or 4 scenes in there. This is one of the scenes from Octane Bench running on an AMD iMac, but it's running on Metal, and it's not running on CUDA. This is a MacBook, Intel integrated graphics, also running ambient occlusion. Obviously not as fast as the discrete AMD GPU, but pretty good. This is about the same speed as we were seeing on an NVIDIA 650 a couple of years back, but this is now running on my MacBook. What's even more interesting is with Metal support, we've also got Octane running on iPad and iPhone. And these are the same Octane Bench scene, direct lighting kernel, the input channels. And what's crazy is that the iPad, the 10.5-inch iPad, is able to ray trace faster than the integrated graphics chip from Intel on my MacBook. And that tells you something. That tells you that it's not the craziest thing in the world to start considering high-end mobile devices as potential candidates for rendering and ray tracing. In fact, one of the things we discovered is that there really isn't any point to CPU ray tracing or rendering at all when an Intel integrated graphics is actually many times faster than the same chip, the same chip CPU cores. And I think that we've seen, certainly on the Apple side, iPads and iPhones increase in speed consistently year to year, especially on the GPU. So these are all on an A10 and an A11. I mean, a potential A12 could be even faster. And there's really the limiting factor that we found when we were running Octane on the iPad and the iPhone was the memory. If you had 8 gigs of video memory, that would be a really compelling device. So for third parties looking to build things on top of this stack, obviously we're using it, we're dogfooding it for Octane. The simplest way to do that is with GLSL. We're building a GLSL front end for the Render SDK, and you can create modules that plug into Octane or Brigade even, or even go lower level, including accessing Urbach, which is our interchange format. And I think a lot of people have been interested in our light field work and our streaming light field work in particular. So all of that is accessible in this SDK. And it has it'll have multiple language front ends, so C#, for example, from Unity would be able to access that as well. And going into the capture side, I mean, the ecosystem of what we want to build is really important. We've had a great relationship with Facebook. We worked with them last year and this year on Surround 360 and on publishing volumetric 6DOF content. And if you see a lot of the results of that, it's really been to integrate volumetric video and capture and workflows with Octane in tools like Unity and After Effects and Nuke. And it's been a really exciting and great learning experience to have Facebook as a partner and Oculus helping us understand, the future of social video sharing, because it's definitely a big part of why we're doing all this and where we see all these things heading. So I want to talk a little bit about light fields and why they're important, and also how this stack works from the capture to the rendering to the publishing phase of this entire ecosystem. So on the left, you see a Disney asset that we scanned in our LightStage, our high-end capture system. We are making that work now on mobile devices. On the right, in fact, you see a Tango device with an ARKit light field stream. In Unity Editor, once a light field is generated, just like a baking job or a light map job, you can then move it around. You have the ability to see it from any angle. It runs 1,000 frames a second. There's really very little cost. And you can then take that Unity application and publish that as an app. But pretty much in this case, we're actually just doing it as a live stream. And on mixed reality devices, in this case it was the Tango, you can do live light field publishing, and that's really cool. But that was a demo. What we want to really support is entire scenes and games and entire experiences that are using light field baking the way that old 2D games use sprites. And that is now possible. We were showing these experiments at Unite Austin last year, where I was taking 2 light fields, mixing them together, streaming them into Unity, and doing that all in VR at full speed. And it was really cool. And light fields do solve one problem, especially the way we do them. We actually don't just have a light field from one basis lighting condition. You can actually relight and cast shadows on these light field objects. So in that sense, it's very much like a mesh or the original scene. You just don't have quite the same flexibility. But when we're talking about mixed reality, we need to have something like that in order to really get mixed reality running on an iOS device, for example. Now, even though we may have Octane one day, we also need to be able to capture the scene. For example, using the cameras to capture the depth in real time, and then turning that into an entire environment and this is our office in LA running at 120 hertz. In fact, I think we tested this inside of Unity to make sure it was working, and it's awesome. I mean, it's a beautiful capture that was literally just captured with the cameras that are on the phone itself. And then this is where these pieces come together, where we want to be able to bring in an object and then have that be lit and have those reflections happen. This is from the phone. All of these things need to occur in unison for mixed reality to really pay off. And our work with this really begins with Octane 4 and its integration in Unity, but there's a lot of work that we have to do on the mobile devices themselves and integrate that really cleanly. And I'm also looking sort of beyond pure AR on the phone to something like this, where I have my iPhone tracking my head, and I have a Vive tracker on the monitor. So it's interesting, because as I'm moving my head, I'm seeing a light field beamed into my eyes, just my left eye at the moment. If it were stereo, I guess I could see both. But it's a great effect. And what it's showing is that having a phone in your hand can track your face, and it could then beam your eyeball's location to another display, which could then beam a light field towards your field of view. And of course, if you had a true light field display, none of this would be necessary. I think that will happen. In fact, in Microsoft's little announcement around DirectX ray tracing, they said, rasterization plus ray tracing is great until you get to a light field display. And I think that may be true, but I think light field displays are really compelling. And this is an example of how we can kind of test how a light field display would really work. And in this case, I have a scene from earlier as a light field on that monitor. But now, I'm moving the monitor, and the light field also moves. So we have continuous tracking between your head, the phone, the display. And this was so that we could see what it would feel like to have a true holographic display panel. And I think those things will really happen. I don't think we're 10 years from the holodeck. I think we're closer to 1.5. So this was really our first foray into investigating this kind of ecosystem. And for me, it was really compelling to have a VR experience like this, or a light field experience with wearing nothing, no glasses at all. I think that in the future, when people can have that in their homes and it's a giant holographic wall, people will want it. I think beyond the obvious tool chain work that we have to do, we've also tried to be a good steward for open standards. We've been participating in MPEG. submitting Urbach as a potential open spec. There's been a lot of learning that's gone on bidirectionally. I've learned a lot from being in MPEG, and I think they've also looked at the 6DoF and volumetric and light field space very differently, and have started to understand that you really almost need a scene graph format. You need to really look at something like Unity and the pipeline that we're building together with them to understand how volumetric content in the future is going to work. It's not going to be pure point clouds or pure light fields. It's going to be probably scene graph systems, very similar to what we're using in Unity and rendering with Octane. The blockchain, as I mentioned before, is really important for us. We launched in October, and we actually have a lot of passionate users of Render. And the idea with Render is we've been looking at GPU cloud rendering as a service for many years. We launched that with Octane 2, in fact. And we keep running out of GPUs, even with partners like Amazon, who are amazing partners. We just, a single customer of the VR render needs thousands of GPUs. Granted, we now have denoising, we have other things we can leverage, but when you're talking about rendering light fields or holographic content or baking those kinds of assets, we need a lot more than the GPUs we have in the public cloud. So the concept of Render was to give the millions of users with GPUs, including Unity developers, the ability to have their renders done by others on their idle time, and also to make Ethereum-backed tokens, which is what Render is, for this work. And we think there's an entire and deep economy of services built around Render that can really be powerful. So that's something that is also going to be part of Octane 4 inside of Unity this year. And I think a truly open metaverse that's both decentralized, that has open formats, that is, allows you to express yourself freely, mix things together. I mean, these things have to be figured out, but this is where things are heading. And I really love this concept, and I love the passion that we see from artists and developers creating things, because I think those are the folks that really understand why something like an open metaverse matters. And I think you have to think like an artist and a creator to really believe in that. And if you happen to have a company like ours that can do something about it, I feel it's our responsibility to try to do that. So we've got a lot of interesting users that are along with us for the ride, and we're really excited and passionate about everything that we're doing with Unity, and we hope you guys are too. So thank you very much. I think we actually have a fair amount of time for some questions. Thank you.
So you were with J.J. Abrams. What was that about?
So JJ is an Octane for Maya user, and I've known him for about 10 years, and he has actually helped me with Render. One of the things that helped push me towards making this thing work was that he also believes in democratizing rendering and democratizing the tools. I don't know if people know this, but he is a Maya user on the Mac. And so we have about 5 or 6 advisors in the company, including a guy named Ari Emanuel, who's been advising me on how all this plays out in Hollywood, and JJ's been a longtime advisor and friend and an Octane user. And it's been fascinating to sort of see his work connected to all of this. I mean, in a sense, this democratizing aspect of us all using Octane means that whether you're doing Star Wars or you're doing a Unity game, we're all kind of now in the same sort of ecosystem.
I have a couple of questions, but
Sure.
First on the light field, how are you simulating that? Like when you're talking about simulating light field rendering, what's your...
You mean in those videos where it was tracking my head? So if you saw some of the earlier videos, or even if I go back a few slides, which I can do, and show you the, how I was working in Unity, where I think it was pretty explicit. If you move that quad around inside of Unity, the camera knows how to bend the rays from the light field data set into your eyes. And the thing is, we've simulated that as well with AR tracking, where I can just drop something in space and there's a quad that's just one, 2 triangles, and the server sends the light field down and it looks correct from your point of view. The problem is I need a device to track, to be that portal. I either need the Unity camera or the phone that has tracking. And the idea with going to this step was that what if there was nothing tracking me other than just was to my face. And so by having the iPhone X just track my head, and essentially have the light field on the TV or on the monitor be beamformed, I had the effect of actually looking into this holographic space and testing that with light fields. And it was the first time that we'd really tried to do that correctly with the iPhone as the intermediary. We had done, the very first test we ever did actually was me putting a DK2 on my head and an iPhone next to me, and you can see that. That's our 2014 light field video, but this was very different. And what we found was the tracking on the iPhone X was really, really, really good, to the point where it was like a sliver of a millimeter made a difference as I was looking at that light field. And I didn't know that. I didn't have that experience, and I couldn't share that knowledge until we tried that out ourselves. And yes, you really should close one eye because it's completely different from between left and right eye. So a true light field display would have stereo, but even the mono effect was insanely compelling. I was really pleased, and I thought it was a really interesting test and experience. And I do think that there is sort of a friction to having a device that's on your head or even in your hand that goes away when you can have something like a light field display. And I'm only holding the camera in this case because I'm trying to shoot a video. So
like a true headless light, like just a wall is what you're
yeah.
saying.
And I think when you get to wall-size light field displays, those will replace windows, and your life will change. Experiences will change dramatically with that.
I have a second question that's
Sure.
different topic, but you mentioned the render token, and curious, when you're talking about decentralizing the GPU rendering, is that sort of like if you have kind of like a bunch of GPU, like anybody out in the world can sort of add their GPU to the farm and then sort of receive some of the profit from the render token?
Yes, and it's really simple. We're building a system tray applet, which we actually launched and let people test it. You can run Octane Bench with it currently. And there's, it was meant to be like SETI at home. Like if you have idle time and you want to set up like a screensaver, you can do that. What we found is there are people that are serious about this and don't want to just do that. They want, one of our users has a 13 GPU rig, which is crazy. I've never seen that. And the reason why is that a lot of this effort and work that's gone into mining Ethereum and tokens, it's a big waste. It's just wasting electricity. It doesn't do anything. Whereas, we have real customers that really, they're paying us to pay Amazon to do all these renders, and we don't have enough GPUs. So if you're basically part of this ecosystem, you're actually using your GPUs for something that's reliable, steady, and useful. And I think that you have two tiers. You'll have the people that are just going to turn on that little system tray and just do render jobs that are idling in the background. I mean, maybe we can even do that on the iPad now that we have Octane running on iOS. But then you're also going to have a lot of miners that have spent a lot of money, on GPUs. 100,000 10Es, right, running, Ethereum mining can switch over to render and should. And I think it would make everyone happier. So we're very excited to see that happen this year.
Just along that same line, how do you secure the assets that are being rendered? So, because one of the big problems
It's a
is,
great question.
like, nobody wants to go and give their assets for the next big movie.
I know. No, it's true. It's true. And it's it's something that was asked from the very beginning. It's something I've been addressing from the beginning. And the way we're dealing with it is having different tiers of content production. And so the first tier is almost what we have now on Amazon, where if you have an MPAA certified data center and they want to be part of the render network, well then you can set your filter to say, I only want to render on these types of nodes. The other two tiers are untrusted, but I will tell you something. There's a lot of render farms that are, that are not that big. I mean, they're out there. They're not MPA certified, and people still do renders on them. And I'm looking at what's going on. I'm like, my God, TeamViewer is on this thing. Your assets are stored on this guy's drive. Like, this is crazy. And at least with the system we have, I mean, it's end-to-end encryption all the way to the GPU, and we're doing our best to work with the GPU companies to have protection in the kernel so that it can be handled safely. And one thing we are doing with Octane 4, which will help, is that you're sending this blob of data. It's not the source geometry or textures. So it's much more obfuscated, and I think that'll help. But the only way to really deal with this is with a tiered system. What's interesting is when you're doing baking jobs, you're already sending, at some point your geometry is going to be in the game, those assets will be there, and maybe for baking jobs the security doesn't matter quite as much, but we are being really conscientious about that the best that we can. And I think going through render is going to be safer than the average render farm out there.
I'm a 3D modeler developer and using the Substance PBR tools for creating games in Unity. I'm just I thought you said something about when you're doing the real-time rendering, you're not using AO, or is there going to be differences in like producing for the Octane render than there would be using just the standard Unity
so
render?
AO I think was a trick created for Pearl Harbor, if I'm not mistaken, which was to quicken the rendering equation. So the rendering equation is just the laws of physics programmed in the computer, and literally there's Kajaya wrote a formula for it, and all the things that have been done even in films like ambient occlusion are tricks. They're shortcuts, and Octane doesn't. I mean, it can turn on ambient occlusion. It can do that. You can also turn on cartoon shading, but the path traced mode in Octane is unbiased. There is no ambient occlusion mode. It just all the rays converge, and you end up with something that looks like a photo or the real world, or sometimes even hyper-realistic. And Substance itself is a material system. So while there may be, in certain cases, a cavity map or an AO map, you can generate that live from from topology or from a bump map, and that's how it should work. So in Octane, that's typically how it's done. And there's a lot less baking that's necessary. You can still bake things, and you can still mix Octane modes together, and direct lighting in Octane is designed so that you can get more speed with things like ambient occlusion, but with denoising, it's almost not necessary anymore. Okay.
Hey, how's it going? For enterprise customers, are you able to use on-premise resources? So at our studio, we have an on-premise render farm with GPUs in it already. And
Yep.
Oh, you can?
Oh, this is for them. Yeah, I mean, the cloud is for the people that don't have 200 GPUs, but yeah, the enterprise license was, the limit used to be 20, and it was a technical limit because we were concerned that people trying to hook up more and more GPUs, they weren't doing it with 10 gig Ethernet, and there's a lot more support. So offering enterprise licenses to the highest end customers is for on-premise rendering, and it's specifically for that. And we added also a USB key, which is much simpler for people to run in airtight networks. So there's a lot of things that are designed for those on-premise render farms.
Are those limited to NVIDIA GPUs with the Volta architecture, or?
Oh no, well it can be any GPU Octane supports, and today that is mostly NVIDIA. Volta is great, but Octane runs just fine on Pascal and Maxwell and Kepler even. So. And we've been working very hard on AMD support, and now with the render SDK and the work that we're doing for Octane 2019, we're really hoping to get every possible device supported correctly. All right. Well, okay.
Back on the render farm, so a lot of GPU miners typically don't have a lot of hard drive space, data space, right?
Yeah.
So obviously that's, to switch over from doing that, how do you get those people to switch over to, do you need the hard drive space, or can it be somehow sent to the cloud?
Yeah, you're right. But the thing is, I actually should point out something, which is our centralized cloud service, which is already accessible in Unity, actually. It's called Org, and Render will replace that. It is currently running a number of jobs on the decentralized network, and so we set up our own nodes to test whether this would work with these 4 phases. And a lot of people that signed up and even bought the tokens of the token cell really wanted to do so to get in early and to do these render jobs. And so I gave out specs for what you should have, and 160 gigabytes of storage is about all you really need. I mean, we don't use that much more because we wipe it out and then we load in another render afterwards, and that's enough. And most people have that. I mean, the blockchain itself for a lot of these things can be tens of gigabytes. So, storage isn't really that much of an issue. I think a lot of people are trying to squeeze more GPUs through on a single motherboard to get more power. But no, I think space is not really that much of an issue.
Okay, fair enough.
Great. Well, thank you all very much. It was a pleasure.